think I know who this is. Do I want to answer? No. We'll let it ring out. I know who that is. Right, okay, so what we're having a look at now is something called linear first order ODE. You're late? Why are you late? No, you're late because you went down that cigarette. I can smell it on you.
It's breakfast, right? Less than 3 minutes.
Doesn't matter, you decided cigarette was more important than Stephen.
No, Stephen, no. That's
Sit down.
That's incorrect.
You've got an addiction problem.
Addiction,
Yeah. Okay, so here I tell you that dy dx equals 1 plus x squared.
Listen.
Yes. Find y. Well, you should have an idea on how I could do that. If I tell you what the derivative is, no,
What's the derivative?
no. I give you the derivative,
Okay.
and I want the y.
What's y?
How can I do that?
But you didn't get the derivative yet.
No, this is the answer. I gave you the derivative. I wanted the original y.
So, 0 and the integration.
So if you know what the derivative is, then the antiderivative can give you back the y. So here, if the derivative is 1 plus x squared, then the y must have been...
1 over 3x cubed.
yes, we'll start from here though. X plus x squared over 2 plus x cubed over 3 plus c. Because we integrated. Do you get the idea that what you're doing here is you start with the derivative, and then by integrating you can get the original. Yeah? So, for example, we could have a problem that's a little bit more difficult. So if I tell you that the derivative minus x cubed equals 0, you don't have to do too much, but you do have to do something to simplify before you can integrate. So what would you need to do here?
So just change it to the other side?
Yeah. So you have here the derivative is equal to x cubed. Therefore, the antiderivative will be 1 over 4 x4 plus c. So this is kind of the basic idea. Let's look at something more difficult. Mm. So far, the problems that we've done we can sum them up like this. You have a derivative and it's equal to some function of x. So all we have to do is integrate. And we have our answer. But take a problem like this. Now, what's different? It's quite different. What's different here?
So to get the derivative of dy to dy?
Almost. But what's the problem here? Or what's different?
We already gave you y.
Yeah, see, the weird thing here is there's no function of x. There's no x, is there?
No.
There's only y.
Mm-hmm.
So, what we do here is we use a technique called separation of variables. Sorry, I left out my A. Separation of variables. Okay, so let me explain that with an example. So for example, if you have dy dx minus y equals 0, the first step is still to equal it like this. The separation of variables says you put the y's on one side and the x's on the other side. So what you do is you bring the dx up to the right, and then you bring the y down to the left. So on the left are y's, and on the right are x's. Y to the left, x to the right.
Can you change it?
No, in fact, it should be this way around because the dy is on the top.
You did dy to the derivative.
Yeah, I can go to the other side then. Yeah. Now what we do next is we integrate. So if I integrate 1 over y, what do I get? Log y. And here there's just like a 1. So if I integrate 1, what do I get? S plus c. Now for this question, I'm going to give you a point. I'm going to say when x is 0, y is 1. And we can use this to find the c. So this will be given in the question. So how can we find the c from that point? Any ideas?
So just put it.
Just put it in, and we get the c. So if I put it in here, I get the c. I get log 1 equals 0 plus c. What's log 1? 0 equals 0 plus c. So what does c equal? 0. So we take this answer and put it back in here.
Why?
Well, we're looking for the c.
But we got c already.
Yeah, so we put the c back in to give our final answer. So our final answer, well, not our final answer, is log y equals x plus 0. Now, it's not quite finished. I don't want log y. I wanted to find y, not log y. So what must I do to finish this? E on both sides. So y equals ex because they cancel here. Yeah? Now, it's a separate question, but they could then ask you to verify. Do we know what this word means? Verify, what does it mean? Check. So let's check that this answer works. If y equals ex, what does dy dx equal? EX. And what was my original equation? It was dy dx minus y equals 0. Now what's dy dx? EX. And what's y?
Yes.
So does EX minus EX equal 0? It does. So you can verify, you can check the answer if you like, that EX is the value of y, the function of y, that makes this equation equal to 0. Okay, let's have a look at something a little bit more difficult than that. Oh yeah, it's just baby stuff right now. Continue down. Sine x dy dx minus cos x equals 0. So we want to find a y so that the derivative multiplied by sine minus cos should equal 0. Again, we have to use the technique separation of variables. So how can we separate these?
Sin x multiply 1 over
Well, bring something to one side first. What do you think, Yemi?
cos x.
Bring cos x to the right. So you get sine x dy dx equals cos x. Okay, what's next then? Oh yeah, and let me tell you the point pi over 2, 0 is on the curve. Okay, Yemi, would you know what to do next?
How do we find the integrate?
Not yet.
Not yet.
Not yet.
I have to figure it. Just swap them.
Not yet, no. We divide by sine x.
Why?
We're getting the x's on one side.
Okay.
So what's next? We should bring the dx up to the right. So what variables are on the left? What variables are on the left? Now what variables on the left? The y variable. And what variables are on the right? X variables. So now we integrate. So when I integrate on the left, what do I get? No. Integrate 1. Integrate 1.
Integrate 1x.
Yeah, but here it's y.
So y equals.
Yeah. Y equals. Now we have to integrate this. Any ideas on what we could do to integrate this?
They change it to tan.
No, sine over cos is tan. This is
So
cos over sine.
tan.
Yeah, but that doesn't help. It makes it more difficult.
Okay. So now I need to tan to tan.
No,
Okay.
no, not this. None of this.
So it doesn't work. Separate them?
No.
I can't get the integration factor of them.
No.
So forget it.
Impossible. Let u equal sine x. So then what does du dx equal? Cos x. So then what does dx equal? Du over cos x. You take this and put it in for dx, and you take this and put it in for sine. So now you get y equals cos x over u du over cos x. What happens here? Tekken, can you actually close that blind? If you, yeah, I have to push your, yeah. Cancel what?
So sin x cosine x.
Yeah.
So I've got now the dy over the
So now you have y equals 1 over u du. No, it's fine, thanks. I think I'll do. Yep. So what is the integration of 1 over u?
log u.
Y equals log u. But what's u? What did we say u was? It was sin x.
Sin x.
So y equals log sin x plus c. How can we find c? We use a point. In the question I said the point was minus pi over 2 and 0. So if I pop that in, I get y equals log sine pi over 2 plus c. Sorry, the y is 0. 0 equals log 1 plus 0. 0 equals 0 plus c. So c equals, again, 0. Pop that back in here. And we get y equals log of sine of x. That's the answer.
Can I ask a question?
Yeah.
So if I look back to the question.
Yes?
Here we use multiplication by parts, isn't it?
No, substitution.
Is there anything indicates to that?
Usually when you have a fraction, you can try letting u equal to the denominator. Another clue is when one part of the problem is a derivative of the another part of the problem. So for example here, the sine and the cos, the sine is a derivative of cos and vice versa. So whenever you see a question that has two parts in it, and one part looks like the derivative of another part, this is another clue as well. So KJ stayed up last night doing his chemistry assignment, and then he submitted it this morning and went back to bed. Would that be kind of the picture I should be imagining? Yeah, another example. But I want you to try this one before I do it. Can I go? Oh no, Yemi. Yeah? So, right near than that. And the point is 1, 0 to help you find the C. So I'll give you a minute to try and do this for me before I just do it. So see what you can do here.
I'm going to use separation of variables.
Yep. How are we doing with this? We got an answer?
No. X plus x squared over 2 plus c.
No.
Far away.
A bit. Let's have a look at it. So, what's the first step? What did you do first, I should say then? What? Nope.
No. I just changed the position of them.
Nope.
Like dy over dx equal 1 minus x dy over dx.
Nope. Step number 1.
Okay.
Factorize on the left.
Factorize.
Right? Makes sense or not?
No.
What's in common here and here? What's in common here and here?
Dy over dx.
Yeah. So, factor. Oh. Now what's next? Now we say dy over dx equals 1 over x plus 1. So dy equals 1 over x plus 1 dx. Integrate dy equals integrate 1 over x plus 1 dx. Integrating on the left, I get y. Integrating on the right, what do I get?
Log x plus 1.
My point is 1, 0. So when I put that in, I get 0 equals log 2 plus c. So that means c equals minus log 2. And I can put that back. So now I get y equals log x plus 1 minus log 2. Y equals log x plus 1 over 2.
X plus 1 over 2.
Yeah?
I'll tell you very correctly.
Say again?
I'll tell you very correctly.
We don't need to verify here. I just did that as an example. I'll do another verify in a minute. But to verify, what you would need to do is calculate the derivative and then put that calculation result into here and here. And when this should add together to make 1.
But still this idea doesn't come out easily.
Oh no, but you're here to learn. Yeah. Okay, can I go to the next one? Let's take an equation like this. This is extremely difficult to solve. In fact, it's a university problem. And here, I'm not asking you to solve. What I'm asking you to do is to verify that y equals ex. Here you go, Yanni. So, in other words, yeah?
Okay.
In other words, I'm asking you to show that this is the answer. This is much easier than finding the answer. So the way we do that is first we calculate the derivative. What's the derivative here? Ex. And then what's the second derivative here? So you take these three and put them back in here. So you'd have 2ex minus ex minus ex. That's 2ex minus 2ex, which equals
0.
So we have verified that this is an answer to the equation. We got it? What's the next lesson called? Yeah. So the reason this is important is we can use this mathematical technique for practical problems in physics, chemistry and biology. So for example, have you done the first order rate law in chemistry for reaction rate? Have you done reaction rate in chemistry?
No.
Are you sure?
What's reaction rate?
Rate of change of concentration per time.
No. Rate of change equals something that we don't know.
You sure you haven't done reaction rate? It's the change in the concentration divided by the change in the time.
Well, I don't know that.
I don't know, guys. I think you might have.
No, we haven't.
I could text Lorraine and say, hey, have your engineers done reaction rate? And she is probably going to say, yes.
Okay, that's good.
Really?
Yeah.
You really want to do this? You feel so confident.
I'm so confident.
So confident.
Extremely confident.
And what about you?
I will do that.
You think you have?
I'm taking. No.
Second?
You tell. No, we haven't done it. Sorry.
I'll ask Lorraine later.
Okay. That will come soon.
We have class later today. I'll update you.
Okay.
Yeah. I think you've done it, but we'll find out later. Okay. Right. So what I want you to do now, just for a few minutes, I want you to try some of these. These are wait. Listen. Come on, listen. These are both section A and section B questions in the exam. Okay. And again, I think every exam I've ever seen in maths for engineering has this topic in section A and or section B. So you really need to be able to do these, okay? The first couple, number 1 until number 4, no, number 1 to number 3, or to number 4, you don't really need anything special, but from 5 onwards, you need separation of variables. You need to separate the x's and the y's. And then in 14, 15, and 16, I ask you to verify the solution. Only verify. Okay? These are the types of questions you get in the exam. These ones here, you know, they could be section A or B. Okay? Alright, try these for a few minutes.